Now we are going to learn about the insertion sort algorithm. So how this algorithm works is that it builds the final sorted list one element at a time, meaning in each iteration only one element is sorted at a time. Okay, so we are iterating through each element and then we insert the element to its correct position in the already sorted part of the list. That means we keep one sorted part in the list and the another one is the rest of the array, right? So in the sorted part we have to position each element on its correct position, and therefore we have two different parts. The first one is the sorted part and the second one is unsorted part. Okay, and all the elements from the unsorted part, they are picked and shifted uh, left until they reach the correct position, meaning since we want to position the element in the sorted part, we have to shift the rest of the elements, and we are actually shifting them to the right. For example, let's take this example. Okay, so we will always start from the index number 1 because we assume that the first element is already sorted, because array with single element is always sorted, right? So the 5 is the sorted part, but the 1 4 2 8, this is unsorted part, right? So we will start from the index 1, and now we are starting from the index 1. The element that we currently on is 1. Now we will compare 1 with the sorted array. So now we compare 1 with 5. So since 1 is greater than, so 1 is smaller than 5 and 5 is greater, therefore what we will do is that we will uh, shift this 5 to 1, right? So it 5 will be shifted towards right. So what it will become is basically it will become 5 5 4 2 8, because we are positioning 5 at this position. Now what we will do at the end is basically we will just make this 5 as the element 1. Okay, because the 5 over here is actually shifted to this position, and now this position is where we are going to insert 1. So now the array will become 1 5 4 2 8. Okay, so now let's start from the second index number 2, which means the third element. Okay, so the third element we will start from 4. Okay, so we will compare 4. So first we will compare 4 with 5. Okay, so we will compare 4 with 5, and since 5 is smaller, what we will do, we will shift 5 to the position of 4. Okay, so what it will become, it will become 1 5 5 2 8. Now we will compare 1 with 4. Okay, but 1 is smaller, therefore we will not shift 1 towards the right. Okay, so we will just move to the right, and over there we will place 4. So it will become 1 4 5 2 8. Okay, now in the third iteration we are going to come to the second element, element 2, which is actually the fourth element at the index 3. Okay, so now we will compare 2 with 5. Since 2 is smaller, we will shift 5 to the position of 2 towards the right. Okay, so it will become 1 4 5 5 8, right? Now we will compare 2 with 4. Again we find that 4 is greater than 2, therefore we will shift this 4 to right. Okay, so it will become 1 4 4 5 8. Now we are comparing 2 with 1, and here we can see that 1 is already smaller than 2, therefore we will not shift 1, and we will go to its right, and there we will position 2. So it will become 1 2 4 5 8. Okay, now we will come to the index number 4 and the element 8, right? So we will be comparing 8 with all of these. So we will compare 8 first with 5. It is already smaller, therefore we do not need to move ahead, since the earlier part is already a sorted array, and we know that 8 is greater than 5, therefore it doesn't make sense to compare with the rest of the elements, since we already know that in this algorithm the first part is the sorted one, in which we want to insert the element at the current position from the uh, rest of the array, which is the unsorted. Okay, so the 8 we will be comparing with 5, but since 8 is bigger, therefore there will be no swapping. And here we are completed with our array and it is finally sorted. Now let's just write code for this algorithm. So firstly, we have to iterate through the whole array, and we will iterate from index number 1 till the we will iterate from index 1 till the end of the nums array, right? So what we want to do is basically we will first store the item that we are currently on, which is the nums of I. Let's store this into um, let's just call it key. Okay, so now what we want to do is we want to compare it with all the preceding elements. That means all the elements that comes before, which contains the sorted part of the array. So starting from I minus 1, we want to iterate while this is the j is greater than equals to 0. Since we want to stay within the array, and we want to check if the nums of j it is greater than the key element. Okay, so if the element is greater than the key element, then we will move the element towards the right. So what we will do is we will make the nums of j plus 1 equals to nums of j, right? And then we want to move towards the left to compare with the rest of the elements in the sorted part of the array. Therefore we will decrement the jth index by 1. Okay, now finally what we are going to do is that now we know that we do not the array is at the now, since we are out of this while loop, meaning that the element that the currently j is pointing at is the one that does not need any swapping. It is smaller than nums of j, right? So what we do is we will move to its right, meaning we will move to the j plus 1 position, and over there insert the we will insert the key element. Okay, so we will make nums of j plus 1 equals to key. All right, so let me submit this solution. Okay, so there is for I in range. This was syntax error. Okay, we are getting an error because I forgot to actually return the nums array, or you can see list in Python. Okay, so it is the test case is passing. Let me submit this solution. And for this one particular problem, it says that you need a solution that works in n log n time complexity. Sadly, the insertion sort algorithm, it doesn't work in n log n time complexity. Therefore, we are getting the time limit exceeded error. If we look at the code, then you can see that we have a outer loop that runs for n element, which is the where n is the length of the nums, and the inner element it also runs in range of n, since it is starting from basically I minus 1, and I can go up to n. So it runs in the time complexity of big O of n square, and we are not using any extra space. Therefore, the space complexity for this one particular solution is big O of 1.